First of all, thank you so much for being here. It's a great honor to be able to speak in such a very nice conference. It's quite interesting. When I just arrived here a few minutes ago, they were talking about wave-particle duality and entanglement, and I was thinking, hey, I brought completely wrong slide deck. But it's also very interesting because now I think it's easier for us other to talk about things when some of you at least has some basic background of what we are discussing. I'm going to talk about the difference between my speech and almost all the other speeches is I am not bringing a solution. I'm bringing a problem. I'm from the industry, and I'm going to come forward with a challenge that I want your companies and your technology to actually solve, because this is a big challenge, not only for us, but for a lot of companies. The challenge that I'm going to talk more about is the challenge of jammed, or even worse, spoofed GPS. But it's not only that, because we are also underwater. I'm going to explain a little bit about what we do, but we also have operations underwater, and there's no GPS underwater. So what we are looking for is something that can give us the position in all domains, and I will talk a little more about that in a bit. First, who are we? I am from a company called Kongsberg in Norway. In the Nordics, it's very known because it's one of the largest companies, but in the world, it's tiny, so most people don't know it. So we have a 200-year existing global player, all blah, blah, blah. Let's skip this, more interesting. We are divided now into 3 different subdomains. So we have Kongsberg Maritime. We are making ships, control systems. We also bought Rolls-Royce Marine, so we have the propeller and these kind of things. Then we have Kongsberg Defense and Aerospace. There we make everything from satellites and to aircraft parts. We make some of the wing parts for the Joint Strike Fighter. We are making the NSM and JSM missiles that you're using on the Joint Strike Fighter. In addition to that, we also make a lot of gun stations and all kinds of equipment. And Kongsberg Discovery, where I'm from, we make sensors, but we also make the sensor carriers. And this is where the problem comes into picture, because if you have an autonomous carrier, you always want to do something with it. It's no sense to just have an autonomous underwater vehicle if it cannot sense anything. Then it makes no sense. If you have a drone that can't sense anything, has no value. So the real value is the sensor. The other part is just the carrier. But then it becomes really important to know where are the sensor. And like if we are looking for a gas leak on the ocean floor, of course we want to know exactly where is the gas leak, which means we need position. And if we are making a drone and we are looking for something and we find an anomaly, we want to know exactly where is the anomaly. Okay, thank you. And the challenge there is that, like on the GPS, in the old days we get jammed, and it was very easy. You know that you have no signal. Okay, you're jammed. Nowadays it's even more complicated because now we get spoofed. And if you get spoofed, you get moved away. And that's even more challenging, as I will show you in a bit, just to get you an overview of what we are doing. So we are from the deep sea explorations. This year, we even launched our own satellite. So we have a satellite that watches the North Sea right now. That is Kongsberg. We do fishing, underwater, naval communication, all these things. But if you look very closely, all of them need communication and position. We need to know where they are. So that doesn't mean that we don't have a solution today. We have what we call the MRU, Motion Reference Unit. It's one of the best in the world. And it has gyros, accelerometers, magnetometers, and it can be connected to GPS and DVLs and all these kind of things. And it gives us a pretty good position estimate. However, all of these need some sort of absolute reference, because if you use only relative reference, over time you will drift. And that's why you have the GPS, which can correlate you every now and then. And underwater, at the moment, we have nothing. So what we do is we use a DVL, which is Doppler sensor, such that we can have a relative motion, which is pretty okay, but not perfect. So what we really need, this is no slide, okay, no problem. what we really need is an equipment that can give us the position in all domains. And we believe that that could be done with some sort of quantum technology. At the moment, we are looking into quantum gyros because the main challenge today is that the gyros drift. And then we use accelerometer to calibrate the gyros, but that's no good because after a while it will actually start to drift off and you know not where you are. Another thing, as you probably know, is that to get your position from an accelerometer, you have to double integrate. And ever so slightly error, you're going to really get lost. So we need to find a different way. What we are looking at is, since on the atomic level, things doesn't drift. So we are thinking if we use a quantum gyro, it will not drift. The problem, of course, is you have to read it out. And the electronic who reads out the quantum gyro, will that drift? Well, we don't know yet. My idea, though, since I'm the director of disruptive technologies, is thinking, are we thinking too easy? Are we thinking just improving what we have? Or should we start thinking, is there something completely different? When they were working on compass and sixcant to navigate, they didn't even think about that we could actually have a GPS. And I believe that there's another solution that we just haven't found yet. We need to get our smartest brains to start working on how can we find position on the planet Earth, underwater or in the air, in a completely new way. And I know that Q-Control is trying. That's good. That's one alternative. But I think there's even better, because I need down to centimeters accuracy. Minutes? Okay. So we are evaluating different existing technologies right now to see to figure out what's best. We have found that on the accelerometer side, classical accelerometers can be made quite good, so it's not really the bad thing. Gyros are the problem. Magnetometers are also a big problem because they're so noisy, right? If you put a magnetometer in a submarine, it's going to be really bad. And as soon as you start turning, it goes crazy. So you can calibrate it, but then when somebody moves something on the submarine, then it's wrong again. So it's really not the nice thing. Then we have what we call north-finding gyros. But the problem with those is that it takes a very long time to find north, and you have to be quite still during that. So they have a calibration time of hours. So this is a big challenge, actually. So we have been looking at different solutions, but we haven't really found the good one yet. And here comes the next thing, I think. Scientists like to do fundamental research, and they don't like to be told what to do. And this is a big problem, because here come I as industry, and I enter into this consortium of scientists, and I say, this is what I want. And they say, no, this is not what we're going to make, because we are going that direction. And this is why I think we need a new shell of scientists. So we need those deep-thinking, basic scientists. That's very important. But we need a group around them, someone who can take what they are doing and look at in the industry perspective and see, can we make something of it? Because people tell me that, oh, now we can measure spin of a photon. And I'm thinking, yeah, and that I can use to what? So I need someone who can tell me, how can we actually use this technology? And it's not a complaint. I mean, I love scientists, but it's just that we need someone who also look in the product way and what can we actually make. And I think also right now we are spending so much money onto the quantum industry. We would have gotten much more money from the industry itself if we had some products. Because right now, to be honest, do we know about almost any quantum products? We have the graviometers, that's okay, but that's used by some few people. We have quantum computers, but they don't really do that well. We have quantum communication, but it doesn't work with the infrastructure. We have some quantum sensor, but they are super expensive and cannot be moved. They have to be like grounded on mountain, because as soon as you move it, they don't work anymore. So that is not really what we need. We need an industrialized, robust kind of product. And also another thing that scientists doesn't realize is that when they have a prototype on their table, then we don't have a product. Then we have a prototype on the table. Then comes the industry. We know how to industrialize, to find the right materials, to find sourcing. We can service, we can sell, we can do all these things. But that has also a lot of value. And this is also sometimes a little bit of a problem because the science industry want us to invest early, but they don't see that we are actually putting in a lot of effort late. So if you look at the entire span of it, I think that the government can sponsor the basic research, and once we got to a certain level, like TRL 0 or 1 at least, then the industry can come in and try say, can we make a product? How can we productize it? How can we make it robust? How can we make it work every time with just a touch? Ease of use, all these kind of things that scientists don't really care so much about. Yeah, I think my time is out. Perfect. Questions? Yes. I think it's a physical problem. I think it's a quantum mechanical problem. I am not sure. Already today we have pretty good algorithms, like we can make super complex Kalman filters, and they can predict drift and these kind of things, but it's not good enough. Remember, if I go underwater in Oslo and go underwater all the way to Denmark, I can get up within a football field right now. That is the accuracy I already have. That is not good enough because I don't know where the pipeline is then. I want to get up in the football goal. So what I'm trying to do is find a sensor that can make me from a few hundred yards down to a tens of yards. And then in the future, even meters. And I'm not sure we can do that purely by software because crap in is crap out. So we have to have something better, especially drift. If it was white Gaussian noise, then it wouldn't matter. That we can easily fix. But drift, that is a different story. One more question? Yeah.
I think using quantum technology for navigation is a research that's going on a lot around the world. And in my research lab, there are people working on quantum position verification, where they use quantum mechanics to verify a person's position. Now, in your firm, are similar research going on with the same quantum position verification?
So I don't know if the same work because I don't really know what you guys are doing. That would be interesting talking to you. So we are basically, at the moment, looking at improving the sensor we already have, which I don't like so much because I like to look at it completely different. So if there's a quantum way of measuring precision, that will be even better. We can do it with magnetic field, but the problem is we are a dual-use company. And the problem is that when we are in the theater, we don't have a baseline. We've never been there before, so then we cannot navigate. So if I fly over countries that isn't so friendly, I will have no navigation. So I need to find something that works there also. And then underwater, we can use graviometers. However, that is super complex because as soon as you start to move a bit up and down or sideways, they will completely be out, and we are talking about extremely accurate measurement. But if your institute has something completely new, that is what we're looking for. Thank you.